Hello, so this is the revision video for the 4Parle test on relative numbers, which involves a lot of work with fractions, finding equivalents, simplifying, comparing, adding, subtracting, and word problems. Hopefully you've tried the questions before you're watching the video. If you haven't, pause here, go back and download the PDF and try the questions first, and then come back and check your methods and your answers. So first of all, we'll just do some work with equivalent fractions. Here you're asked to fill in the missing numbers. And equivalent fractions are fractions that just have exactly the same value, but the numbers are clearly different. So the first one here, we have 2/3. We want various different fractions that are equivalent to 2/3. The rule is basically quite simple. You multiply the numerator and the denominator by the same value to get an equivalent fraction. So if we look at the first one here, we've gone from thirds to sixths. So what we've done is we've multiplied this by 2. So we multiply the top by 2, and 2 times 2 is then equal to 4. So 2/3 is equal to 4/6. Now the next one is 6 over something. So our numerator is now 6. To go from 2 to 6, we multiply by 3. So the denominator I multiply by 3. 3 times 3 is 9. So 2/3 is also equal to 6/9, and in fact 4/6 is also equal to 6/9 as well. These are all equivalent. The next one is over 30. So this is quite simple, because if our denominator was 3 and now it's 30, I've multiplied by 10. Multiply the top by 10. 2 times 10 is 20. So 20 over 30. And then the final one here, I've gone from 3 to 18. So I've multiplied that by 6. So I multiply the top by 6. 2 times 6 is 12. So 12/18 is also equal to all of those other fractions, including 2/3. The ones below now, we have 4 over 10. 4 over 10 is something over 5. To go from 10 to 5, I have divided by 2. So the top here, I divide by 2. And sometimes we actually like to show that. So we can actually show a little arrow here, say divide by 2 going that way. And that's a nice, just to show what method I'm using. I'll use that on the other ones here. The one below, I've gone from 7 to 14. So clearly that's a multiply by 2. So if I multiply the top by 2, I have to multiply the bottom by 2, and 8 times 2 is 16. The next one then, I've got 15 to 45, so I've multiplied that by 3. So I multiply the top by 3. It's a negative number, so be careful with that. You see the little negative sign here. So it's -2 multiplied by 3. -2 times 3 is -6. And then the final one here, the top here is multiplied by 2. And then the numerator here, so the denominator will be also multiplied by 2. -5 times by 2 is -10. Simplifying fractions. Simplifying fractions is similar to equivalent fractions, but we want the smallest possible denominator, smallest possible number on the bottom. So the first one here is 4 over 6. So I'm looking for the highest common factor for both 4 and 6. That's the biggest number that goes into both. Well, if we look at it, the only number that goes into both apart from 1, and 1 wouldn't change my fraction, is 2. So I would divide the bottom and the top by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So the simplest version of my fraction here is 2/3. Moving across, we've got 10 over 25. Both of those divide by 5. 5 is the biggest number that goes into both. So divide top and bottom by 5. I'm going to get 2 over 5, so 2/5. And then the next one here, I'm going to divide by 2, because both numbers are even. So I know they're going to clearly both divide by 2. That's going to give me 3 over 20. And that number then is in its simplest form. The next one, let's just say I don't know what is the biggest common factor of 18 and 24, but I do know that they're both even. So if they're both even, I can divide both by 2. So I can divide the top by 2, I'm going to get 9. I can divide the bottom by 2, and I'm going to get 12. Now I look at those numbers again and go, oh, look, I can divide top and bottom by 3. So we go again. We say, okay, let's just divide by 3. So 9 divided by 3 is 3. And 12 divided by 3 is 4. And looking at that, nothing goes into 3 and 4. So that must be my simplest form. So you can do that in stages. Or if you look at it, you could have just gone straight from here to here, and instead of dividing by 2 and then by 3, I will just divide by 6. 6 is the highest common factor of both, and that would have taken me to 3 over 4. Either method is fine. So if you can do it in one go, great. If not, do it in steps. There's nothing wrong with that. You will not lose any marks by doing it in steps. The final one here, I'll do that one in steps as well. Both numbers are even, so I will just very quickly divide by 2. 20 divided by 2 is 10, and 16 divided by 2 is 8. Both those numbers are even as well, so I can do 10 divided by 2 is 5, and I can do 8 divided by 2 is 4, and gives me 5 over 4. I could have, of course, gone straight away from 20 over 16 to 5 over 4 by just dividing by 4. I could have done 4 in one go. It makes no difference. You still get to the same answer. Now, you will be asked to compare fractions, and to compare fractions, you will be using these symbols here. So this is less than, greater than, and equals. To compare fractions, the denominators, the bottoms, must be the same before you can compare. Although there is an exception, and I will go through that. Hopefully you spotted it when you did the questions. So let's look at the first one. I've got 1 over 6 and 2 over 9. I know that 1 over 6 can be rewritten as 3 over 18. And I know that 2 over 9 can also be rewritten as a denominator of 18. And this time it's going to be 4 over 18. So 1 over 6 is the same as 3 over 18. 2 over 9 is the same as 4 over 18. And then I can compare these two fractions. And I know that 3 over 18 is less than 4 over 18. Which means, therefore, that 1/6 must be less than 2 over 9. You really need to show all of this workings for a question like this. So you convert both fractions so they have the same denominator, using the rules of equivalent fractions. Then you look at the tops of these fractions, say which number is bigger. 4 is bigger than 3. So there's my symbol there. 3/18 is less than 4 over 18. And then you rewrite the original fractions using the same symbol, the same way around. Next one's got negatives on there, but that really shouldn't be too confusing. I need the same denominator. So 4 minus 4 over 5, well, that's going to be equal to minus 16 over 20. I'm going to go for 20 for my common denominator. Minus 3 over 4 is equal to minus 15 over 20. So which number is bigger? Sometimes with the negatives, it can be a little bit confusing. I like to look at them or think of them as being on a number line. So if you actually had them on a number line, you marked them out on a number line, you would have positive numbers going that way, and obviously the negative numbers going this way. We would have negative 15 over 20 here, and then to the left of it, somewhere you would have negative 16 over 20. The bigger numbers are to the right, the smaller numbers are to the left. So this tells me then that basically the negative 15 over 20 is larger than negative 16 over 20. So negative 16 over 20 is less than negative 15 over 20. So that means then that what I have is minus 4 over 5 is less than minus 3 over 4. Take a minute just to reflect on that one, because these ones can be a little bit confusing. Imagine where they are on the number line. Numbers to the right are bigger than numbers to the left. Okay, the next one. We've got negatives here, but if you look at it, we don't need to worry about the common denominators. What have we got here? We've got minus 6 over 10, that's fine. And we've got minus 6 over minus 10. Well, that's a negative over a negative. Negative divided by a negative is positive. So actually, that fraction is just equal to 6 over 10. And 6 over 10 is clearly larger than minus 6 over 10. So minus 6 over 10 is less than 6 over 10. They're basically either side of the 0 on the number line. So therefore, minus 6 over 10 is less than minus 6 over minus 10. That one again can catch people out. The final one here, I could try and do some strange denominator, which is the multiple of 8 and 24, but if you look at it, 8 goes into 24. So I can just take my 7 over 8 and make it a fraction over 24. that would be multiplying the bottom by 3, so therefore multiply the top by 3, and that gives me 21 over 24. And clearly, 21 over 24 equals 21 over 24. It's the same fraction. So therefore, 7 over 8 equals 21 over 24. Now, with these examples, I didn't have any that were written as greater than, with the greater than symbol here. Clearly, it just depends on the order that you write your answer. So just as a point of reference, going back to the very first one, when I said that 1/6 was less than 2/9, I could have written that 2/9 is greater than 1/6. And just notice the symbol is now the other way around. I think a nice way of looking at this is the gap here is bigger than the point. So the gap is always where the larger number is. So this one is larger than this one is larger than this one, and so on. So that might be a little hint just to help you.